Okay. So we're gonna finish up chapter 4 today. We're gonna look at 4.3 and 4.6. We're not doing 4.4, 4.5. Those two homework assignments are not part of your list anyway, so you don't have to worry about those. So today we're going to look at relative position. We're going to look at percentiles. We're going to look at the box and whisker plot, and we're going to get an actual definition for how to find outliers as well. So if at some point you went to a doctor's office, you probably saw a chart like this. If you have a little kid, you're definitely going to see a chart like this. If you're a nursing student, you're going to see a chart like this. All right. This is the length for age and weight for age of birth to 24 months for boys. They have one similar for girls as well. So what that graph has on it is what's known as percentiles. So a percentile is a value that says that percent of data there's a percentage of data that is less than or equal to that point. Okay, so if you're in the 95th percentile, that means 95% of all the data are below you. If you're in the 60th percentile, it means 60% of the people are below you. Depending on when you took the SATs or if you took the SATs, because not everybody has to take them nowadays, one of the things that you got back with your SAT report was what percentile you were in with math and what percentile you were in with English. That means basically what percentage of students you beat. So you'd want to be up in the upper end of that scale. If we look at this chart that I briefly showed you, and I'm going to show you again, except we're just going to look at the weight side of it. So here's that chart. So you'll see that line right there, that middle line, is the 50th percentile. So that line right there is the 50th percentile. That would be considered average. Okay. That's where you'd actually want to be. If you're down in this range, you're severely under, in this case, weight. Okay. This is 5% and 2% percentile. And if you're up in this area, this is over. That'd be overweight, and that'd be underweight. So percentile tells you where you are. Now, depending on the percentile, depends on what that means. So in terms of the SATs, if you're in the 95th or 98th percentile, that'd be amazing. That means you're beating 95 or 98% of all the students who took the SATs. If you're a 24-month-old that is about 35 pounds, that means you weigh more than 98% of all the babies at 2 years old, which would not be a good thing. You're overweight. So unfortunately, a lot of parents, when they go and speak to the doctor, and the doctor tells them, oh, you're in the 98 or the 95th percentile, they're happy with that because they don't understand what percentiles mean. And they just hear 95%, and they're used to school where the higher the percent, closer to 100, the better you are. So when you get those numbers, you also have to understand the meaning behind them. And that's why I like to show this graph, because it's one of those situations where you don't necessarily want to be at the upper end or the lower end. You want to be in the middle. You want to be in the 50th percentile. That means you are average, which is a good thing in terms of height and weight. More so in weight than height. To find percentile, they had this nice little definition, but I kind of like the flow chart better, so we're going to use the flow chart. The first thing you need to do is just like we did with median. All the information has to be put in order. Yes.
Is that symbol on is that an L?
Yes. It stands for location. So yeah, that's an L. This stands for location. So the location of the percentile we find by taking n, which is the number of observed in data, so it's basically all the pieces, times p over 100. So p would be the percentage you're looking at. Remember, percentages is just a decimal. So if you're looking, you don't necessarily have to do p divided by 100. You can just move the decimal 2 places. So if we're looking for the 50th percentile, we'd be looking for 0.5, for example. So that all that does is just divide it to change it into a decimal. The next part is important. If that L comes out to be an integer, what's an integer? Anybody? Yes. Yeah. No decimals. So if it comes out to be an integer, which means no decimal, we need to do one thing. And if it comes out to not be an integer, we need to do a different thing. So if it comes out to be an integer, you need to take that number and the one next to it and average them. So if it comes out to be a whole number, you're taking that point and the one next to it, adding them up and dividing by 2. If it does not come out to be an integer, you're always rounding up. And that's the number you would choose. Okay? So if it's an integer, we're taking that number and the next one, adding and dividing by 2. If it's not an integer, if it has a decimal in it, you're always going to round up and take that number. Yes.
When you do the next number, would that be like the higher number, not like the one? Like, I know there would be 2 numbers on each side.
Yeah. So we're going to do an example of this in a minute. But so let's say it came out to be L was the 12th number. I would take the 12th number and the 13th number in the list, add them and divide by 2. If it came out to be 12.3, I would take the 13th number. If it came out to be 12.9, I would take the 13th number. You're not rounding in terms of how to round. You're literally always rounding up and taking that number. So if you think about it, we kind of did this when we were looking for median, right? Median is in essence the 50th percentile. That's the middle number. So if it came out to be, if we took 10 numbers, we divide that in half, you get 5, right? We would take the 5th number and the 6th number, add them up and divide by 2. If it came out was 9 numbers and it came out to be 5.5 or 4.5, I would take the 5th number. There was only one number left in that spot. So in that essence, it's the exact same thing we did with median. Just this works for any percentage and not just the middle number. All right, let's actually do this so you can see how it actually works. All right, so here is my numbers. This is the number of spelling errors found on 7 web pages. And we want to find the 50th percentile. So what's step 1? What's the first thing I have to do to these? Put them in order. Very good. Always make sure you put them in order. So I have how many numbers? 7. So that's n. and I'm multiplying it by the 50th percentile, which would be 0.50, which gives me what? 3.5. Is that an integer? No, so I round up. So that goes to 4. So I'm going to take the fourth number. 1, 2, 3, 4. And 3 is the 50th percentile. What if I wanted to find the 80th percentile? So I'd multiply 7 by 0.8, which gives me what? That's 7 times 0.8. Is that an integer? No. So round up. So I'm going to take in the sixth number. So that would be my 80th percentile. Okay. Does that make sense? Okay. Let me erase the non-ordered list. Okay. There's 40 people in here, so you don't have to count them. I want the 10th percentile and the 88th percentile. All right. The 10th percentile comes out to be 4. Is that an integer? Yes. So that means I'm looking at which numbers? The fourth number and the fifth number. So 1, 2, 3, 4, and 5. So those two numbers are the ones I'm looking at. Okay, because it's an integer, I take that number and the next one. So then we're going to take those and divide them by, add them up and divide by 2. So my 10th percentile number is going to be 28. Does that make sense?
After you get them, you add them up and divide by.
Add them up and divide by 2. You're looking for the number, the middle number, basically, between those two. So your percentiles do not necessarily have to be a number on the list, just like your median doesn't. It can be a number that's not in the list. Your 88th percentile was 35.2. Is that an integer? No. So I round up, and I'm looking at the 36th number. And that'd be 73. What's the 50th percentile?
So that would be 54.
Why is it 54?
Oh, so, yeah, no, it is 54, because the two numbers are 54, so it would just be 5 4.
Right. Because if I multiplied 40 by 0.5, I get 20. So I'm looking at the 20th number and the 21st number. So I'm looking at that number here and the 21st number, which both happen to be 54. So the 50th percentile is 54, because 54 plus 54 divided by 2 is still 54. Okay. Okay, cool. So do you understand the difference between when you have it as an integer and when you have it as not an integer? Okay. The other thing that we can do is we can determine what percentile a number is. Okay. So, yeah. So if I was looking at, let's say I want to find, actually, I'm just going to duplicate this slide. Give me 1 second. Okay. Let's say I look at number 57. So I'm looking at that number right there. I want to find out what percentile that number is. So we're looking for the number of data values less than that divided by the total number. So the total was 40. How many numbers are less than 57?
57. Oh, on there.
On the list.
Okay.
Good. You gave me the answer that I was expecting somebody to give me. Yeah, we want to look at the numbers in the list. So how many numbers are lower than 57 in the list? 24. So we're going to take 24 and divide it by 40. Which gives me what?
5.1.
Nope. 0.6.
Oh, yeah.
So 57 is the 60th percentile. Okay. Yes. So your percentile is the number of data values less than or equal to it. So it's like it's going down. And the total number of data values. So in this case, that's 60th percentile. Yes.
Like less than or equal to, if that doesn't mean that saying that you count the number itself, but there was a duplicate, you.
Yeah. Exactly. All right. So we have our percentiles, which could be any of them. But we have three very specific ones that we use a lot. And they're known as our quartiles. So our quartiles are the 25th percentile, 50th, and 75th. They're the quarters. Okay. Q1 is 25. Q2 is 50th, the 50th, which is also known as your median. And Q3 is 75%. So you will, actually, we'll do that in a second. The next piece that's important is, remember I talked about yesterday, we talked about a Monday range, and I said there's going to be another range that's really important. This is the interquartile range. The interquartile range is between Q3 and Q1. So range is from the min to the max. Interquartile range is looking for the 75th percentile, the 25th percentile to 75th percentile. So it's looking for that middle half, basically. All right.
You have River?
Yeah. No worries. No problem. All right. So let's go back. To this set again. All right. So find me my 25th percentile, 50th percentile, which we already did. It's 54, and 75th percentile for this set of numbers. All right. So what's Q1?
42.
So we got 10 numbers. So we look at the 10th and the 11th number. So 41 and 43. Add them up, divide by 2, you get 42. And what's the 75th percentile? So you should have gotten 30. So we're looking at the 30th number and the 31st number. So 64 and 66, which is 65. What's the minimum number?
18.
And the max number?
82.
What's the range? So range, you're taking the highest number and the lowest number and subtracting it. What's the interquartile range, which you'll always see me abbreviate as IQR? I will never write out interquartile range. It's too long. Yes, because we're taking the 65 and the 42, which is 23. Any questions on how we found any of that information? Good. So that gives me what's known as my box and whisker plot, and is also known as your 5-number summary. So if you look at this box and whisker plot at the top, you will see the 5 numbers that we just got. the minimum is 18. The first quartile Q1 is 42. The second quartile or the median is 54. The third quartile is 65. And the maximum was 82. That is known as a 5-number summary. Those 5 pieces of information. So if we look at the box and whisker plot, it's known as a box. They call it a box plot. I always call it a box and whisker plot because you have the box in the middle and then the whiskers going on the sides. So this is Q1 right here. So what does Q1 represent? What's the percentile for Q1? 25, right? Which means there is 25% of all the data between that line and that line. Between Q1 and the median, how much do you have? So Q1 is 25%, median or Q2 is 50%. So what percent do you have between those two? 25%. That means in this little red box, there's 25% of all the data. In the blue box, there's 25% of all the data. And over here, there's 25% of all the points. So in this case, there was 40 data points, right? So there's 10 points in each of those. The bar tells you how spread out those 10 points are. So we went from 18 to 42 for the first 10. Inside here, there's 50% of the numbers. There was only 23 of them. So with the box and whisker plot, you can start to see how spread the data is. So we go back to what we were talking about before when we were looking at how the variance of the data, how spread out the data is. The bigger those boxes are, the more spread out that information is. Does that make sense? Okay, does everybody see how we created that box and whisker plot? So we're looking at each of those values is a line. Your middle, your Q1 and your Q2 and Q3 make that box in the middle. And then you have the whiskers going out to the min and the max. So we talked about an outlier before, but now let's get an official definition of an outlier. An outlier is 1.5 times the interquartile range. So my interquartile range, the last one was what, 23? I remember right? Yeah. So my IQR in the last problem was 23. So we're going to take that. So your outlier is 1.5 times your interquartile range. So 1.5 times 23 in this situation. So we get 34.5, and we always round up, so that's 35. So that means my number has to be 35 above the 75th percentile or 35 below the 25th percentile. So in this case, my 25th percentile was 42 and 65. So Q1 was 42. So my outlier here would be 42 minus 35, which would be any numbers less than 7 or 7 or below. And Q3 was it 65? Yeah. So 65 plus 35, which would be 100. So any numbers greater than 100 would be an outlier. So if we look back at these numbers, do I have any numbers that are less than 7 or 7 or less than? No. Do I have any numbers 100 or greater? No. So I do not have any outliers in this information. So there's an actual definition for an outlier. It's 1.5 times the interquartile range above the 75th percentile, or 1.5 times less than the 25th percentile. Okay. All right. Yes.
And so for that, you don't do anything with 50, that's like considered like the average. So
That's just the median. So basically what we're looking at, if you're looking at these the box, we're looking at this line here and that line there. So there's only a certain level that this line will go down to before we would consider that an outlier, because it's too far away from that box in the middle. All right, your turn. So here is the shown the film. This was the scores they gave a film. Yeah. So these are the scores. So we want Q1, Q2, Q3. The interquartile range, make me a box and whisker plot and tell me if there's any outliers. Don't forget to put them in order first. I missed numbers. Okay. I've got all the numbers. Now that I have the answer, make me my data plot. It's important to try this. For the middle number? Oh, okay. What'd you get? There is 30. That's right.
Yeah.
Q1. Q1's not 8. I think it's the 8th number.
Oh, okay.
So what's the 8th number in the list? Is the question. That's that. Your median is not 66.
Okay. Other at the bottom.
So when you open up Rugio or Rugeru, they give you a blank list. You can type all your numbers in there. And then if you click the little hold on, I have to save it again. You have to save. You click the little thing there. It gives you your there's Q1, there's Q2, there's Q3. There's your min, there's your max. Almost everybody was doing it up by hand. Never said you had to do it up by hand.
I need to sign in the computer.
Huh?
Then I need to sign in.
Well, then yes, then you'd have to sign in the computer. But you can start to see like so 30 points isn't a ton, but it does make your life a little bit easier. Once we have those numbers there, that's our 5 data summary. Now, it will also make you a box plot. There's the box plot of the variables. But the box plot is actually something that we can easily do. Once we have those 5 numbers. So first thing we have to do is figure out is there any outliers? So what's my interquartile range? Because that they did not calculate for us.
It is 41.
So we're going from Q1 to Q3, right? Which in this case actually is 44.
I don't know why I wrote that. Yeah, no, you're right. No,
It's okay.
I have it as 84, but I wrote it as 81 for some reason.
There you go. It happens. All right. So then we're going to figure out outliers. I need to multiply that by 1.5. Okay. So I'm going to go down 66 from 40, right? And that's going to be a negative number. So I know that's not going to work. And if I go up 66 from 84, I'm above the 100, correct? So there is no outliers. In this one. So let's make our quick little box whisker plot. You don't have to make it anything special. Okay. We can easily just do a nice little quick little number line. So my min is at 26. So that's about like right there. My Q1 is at 40. My median is at 61. My Q3 is at 84. And my max is at 100. There's my box and whisker plot. So once you get the 5 number summary, box and whisker plot's a piece of cake. So one of the things that using Rugio or that other site is really helpful for is they've got data sets already built in. So this data set's called Moneyball. And the question was they wanted to do a box and whisker plot for on-base percentage. So if we wanted to get, I don't think that one. If we wanted to get the 5-number summary for this, we can easily click that. No. Save. I always forget to hit save before I hit that. And we scroll down to on base percentage, and we can see our Q1, our min, our Q1, our median, and our max. So they're right there. So what's my interquartile range? So I'm doing 0.337 minus 0.317, right? Because we're looking at the blue. So what do we get? That's my interquartile range? Yes? No? So these numbers, yeah, there's something about baseball, but in the grand scheme of things, you don't. All your numbers don't have to be whole numbers. You can still do calculations on them. So my interquartile range doesn't change. I'm still subtracting the Q1 from the Q3, or the Q3 from Q1. So I get 0.02. If I multiply that by the 1.5, what do I get? Okay, so now I'm going to subtract that from Q1 minus 0.030. And what do you get? And then if we add to the top, we get 0.367. Look at my min and my max. Are they in that outlier range? Yeah. So I have outliers in this data set. Now this data set has over almost 1,300 values in it. This is not a small data set. This is not one you'd be able to do out by hand. So I've got some outliers in it though. So how would you show that as a box and whisker plot? So this is the box and whisker plot. So when you're looking at the lines, that's Q1, that's the median or Q2, and that's Q3. This and this line, that is not my min and my max. Yes. Yeah.
Cutting off the outlier.
Right. This is 0.287, and this is 0.367. So your bars will only go out as far as the end of where your outliers begin. Okay. And then, as you can see, I've got some outliers up here, and I've got a bunch of outliers down here. Okay. So you would mark your bars at the extent of your range for your outliers, and then you'd put dots past it for any outliers. And if you look at the actual data set, those were my outliers on the low end. So I had 1, 2, 3, 4, 5, 6, 7 outliers on the low end. So I think one of the questions came up because can you have multiple outliers? Yes. Because there's so many data points in this one, those are all down there. They're not pulling it so far down that we don't have multiple outliers. And if we look at the other direction, my other direction was what, 6, 7? So I have just those two as my outliers. Oh, they actually gauge. No, they didn't. So both outliers were done by Cleveland Indian on the low end. I mean, on the high end. And those are your low ends. See, most of the low ends were actually, most of the outliers in the low end were all back in the 1960s. Oh, yeah. They were a really, really bad team those few years, but they were an expansion team. That's why. So you can start to look at that type of data, and that's where that box of whisker plot really helps you look at it. We were looking, there was 1,200 data points, 1,232. This box of whisker plot shows us all that information in one little thing. We can see that the vast majority of people, 50% of all of them, are in that little box in the middle. So the majority of the cases are right there. Okay. And that's one that you would not be able to do out by hand. It's not. Yeah.
I would think that the majority of.
You're not doing it by hand.
Yeah,
Yes.
you wouldn't do it
No.
by hand.
No.
But
So one of the other things, actually, let me pull up this because you can do with these. So here is U.S. violent crime rate per 100,000 residents from 2010 to 2014. So you can see the breakdown of the data of all these different cities in the United States, and they did a box and whisker plot for each one. These are vertical, doesn't change the thing, it's just another way to show it. You'll typically see a lot of them when you're comparing them as being vertical. So you can see how these numbers right here, those are actually outliers. I wonder if they actually tell what the outliers. Oh, that's actually the crime rate in Washington, D.C. is the outlier value. That said something. So when you're looking at these, though, we can start to see trends. So what do you notice about the boxes as they go from left to right? Huh? What do you notice about the boxes as they go left to right? They're getting bigger, they're getting smaller, they're staying the same.
I mean, they're staying around this, they're sort of staying the same like size, but they are sort of. Yeah, well, they are getting smaller. They're like.
Okay, so they're compressing.
Yeah. Right.
Okay, so and that's where so when you're looking at so that means that remember the boxes aren't the values. So the boxes are telling you that there's 50% of all the cities are falling in this range. So as they're compressing, that means that 50% are getting into that smaller and smaller space. Okay, so if you look, the top line does seem to be going down a little bit. So that Q3 is going down. The Q1 seems to be staying about the same. It dropped a little bit, but then it goes up. So the Q1 value really isn't changing much. Yeah.
And the max are also growing, I guess you can say. I mean, 2010 to 2014, 2014 is lower, but it's about the same. It's about on par with everyone else.
Yeah. So you can start to see, like, that's what I'm saying. You can start to see the trends when you're looking at multiple bar graphs, like, or multiple box and whisker plots like this. So here's a question. Can a person who does not have a high school diploma earn more than somebody that has an advanced degree?
Yeah.
So what would we be looking at to compare those two?
The line, the maximum.
Right. We'd look at the max here, right? Is that higher than the minimum on the advanced degree? Yeah. So you could have somebody that does not have a high school diploma earning more than somebody that has an advanced degree. Okay. As you can see these bars, as you get a higher and higher degree, yes, you can earn more, but the spread is a lot more. There's a lot more variation as you're getting higher and higher. So the low end definitely going up. All of them are definitely going up. But since it's so much more spread at the upper end, you can start to see where, like, even if you had a bachelor's degree, you could earn well over 75% of what the advanced degrees are. So getting an advanced degree doesn't automatically mean you're going to make a lot more money than anything below. It really depends on your field and a lot of other things. So that's where that falls in. All right, one more thing. This is a really simple. The 4.6 is actually really simple. It's just it's proportions. All proportions is what you want over the total. It's a percent. You're just dividing by it. So suppose your statistics class is composed of 48 students, 4 are left-handed. What proportion of the class is left-handed? I take 4 and I divide it by 48. And I get what? So 8.3%. That's a proportion. All right, last problem. What percentage of Americans certainly would not be able to produce $2,000 in the event of an emergency, according to the study? Probably everybody in this room. So, how many people did they study? So, I'm looking at the bottom number is 1,900. And how many people certainly wouldn't be able to do it? 532. So, divide that. What do you get? So 0.28 or 28%. So 28% of the population would certainly not be able to produce 2,000 in the event of an emergency. What percentage of Americans would probably not be able to pay a $2,000 bill in 30 days if required? What is it? How'd you get it? Okay. And which number did you get? Sorry, I didn't write it down. 0.22 or 22%. Would this group of people not be able to do it too? Would the certainly group probably not be able to do it?
Yeah.
So
Total 50%.
shouldn't this be 950 then? You took this number because that's the number they said right there. Totally makes sense. But I would argue that this group right here also would not be able to do it. So they would also fall into that group of they probably wouldn't be able to do it. So 50% of the people in the country would probably not be able to pay a bill of $2,000 if they were given 30 days. And this was done in, did they do this one? Oh, they actually don't tell you the year. It's probably way worse than that now. All right. Your test is Wednesday.